In this video, we're going to look at representing inequalities graphically. We're going to look at shading regions that satisfy inequalities in both x and y. So these are linear inequalities. An example could be x is greater than 3, or we could have y is equal to or less than 1. We might, for example, have y is greater than 2x plus 1. So all we're going to do is look at graphing these inequalities and shading the regions that satisfy one or more of these inequalities. Let's start off by looking at the lines that we're going to use. If we have a strict inequality, so for example this one where we can't include 3, we're going to have a broken line, like so. If we can include the number, like we've got here, y is equal to or less than 1, we would have a solid line. So what we're going to do is look at graphing the lines and then shading the regions. So let's start off with a nice straightforward example. We're asked to shade the region of points that satisfies x is greater than 3. We're asked to label the region R. Let's start off by looking at horizontal and vertical lines. For example, if I had the line x is equal to 4, what we would do is simply locate the x-coordinate of 4 and draw a vertical line. So if we have x is equal to something, that is simply a vertical line. If we have y is equal to, for example, 1, we would just locate 1 on the y-axis and draw a horizontal line across. So when we have x, what we're going to have is a vertical line. When we have y, we're going to have a horizontal line. When we're using inequalities, of course, we'll have our broken lines where necessary. So if I look at this one here, what I need to do is locate x is equal to 3. We know that it's a strict inequality, so all I'm going to do is draw this broken line here. What we now need to do is shade the region that satisfies this inequality. If you're unsure, you can test a point. I certainly think with these examples it's quite clear to see that all numbers to the right of this line are going to be greater than 3. So all we would do is simply shade out this part right here, and obviously your shading would be better, mine's a bit messy, but it gives you some idea of what we're going to do. And then I would simply label that region R. So I'm going to put here that this is the region that satisfies that inequality. So if you look here, we've got all numbers for x greater and strictly greater than 3. So we don't include 3, and that's shown by the broken line. So integer values could be 4, 5, 6, right the way up, and you can keep going all the way to the right. So shade the region of points that satisfy x is greater than 3. What I always do if I'm unsure is test the origin. If I test the origin here to see which side I need to shade, well, this is 0, 0. X is 0 here and y is 0 here. So if we want the numbers now that are going to be greater than 3, clearly 0 is not greater than 3, so we don't shade to the left of the line. I think that's blindingly obvious in this particular case, but the examples we look at later might be slightly more challenging. Okay, we're asked to shade the region of points that satisfy the inequality y is equal to or greater than 2. We need to label the region R. So we can include 2 this time. All I need to do is get a solid line and locate the line y is equal to 2. We discussed that this was a horizontal line at the point now where all of the y coordinates are 2. Just think about what's happening here. This point here is going to be 0, 2. This point is going to be 1, 2. This is going to be 2, 2. We've got 3, 2, 4, 2, and 5, 2, and so on and so forth. Again, I've only got part of the coordinate axis here. So I only cut this down to x up to 5 and a bit and y up to 5 and a bit. But what you can see on this line, all of the y coordinates are 2. So what we need to do here is go ahead and shade what we want. Well, this clearly now is going to be equal to or greater than 2. So it's going to be above the line. So all I do is simply shade above the line, and I would shade this better. I would simply get a nice pencil and a ruler, put the ruler on this particular line here and come down to it and make a nice little shaded area. So that is a region we're interested in. If you want to test a point, if you think I'm really not sure if I've chosen the right one, test the origin. 0, 0. The y coordinate here is 0. Is 0 greater than 2? No, it's not, so we don't shade below the line. Okay, we now need to shade the region of points that satisfies y is less than 2 and x is greater than 1. So what we've got here are two inequalities to represent, one in x, one in y. These are both strict inequalities, and we're going to go ahead and do them individually. So all I'm going to do is go ahead now and look at this. We need that y is strictly less than 2. So that's the line y is equal to 2. So we would have all of the points below this line. It's entirely up to you if you want to shade these now. Often if I have a pencil, I do this incredibly lightly, massively lightly. Because if you put, for example, 2 or 3 inequalities on and then forget what you're doing, you might have wished you'd shaded to begin with. I'm not going to do that, but what we're interested in, if y is less than 2, that would be all below this line. What we now need is that x is going to be greater than 1. So what I've got here are two lines. The line here, let's just put this on, this is the line y is equal to 2, and this is the line x is equal to 1. So we want all points that are less than 2, the y coordinate, and bigger than 1 on the x coordinate. Well, we can see that that's going to be this side right here. Because when I would have originally shaded, I would have shaded all of this below. If I simply shaded that x is greater than 1, I'd shade all of this to here. So it needs to be the part that satisfies both. Another way we could look at this is to get two different colours. So, for example, if I shaded the first one, so let's go ahead and shade this. This might be quite forgiving. No, it's not. Let's just, so all of this below, this would have been our first one, but y is less than 2, all down here, and I could have kept this going. And then I would have done it now that x is going to be greater than 1, which if we did this one right here, this is what we're going to get. So we're going to get all of this now. And what we would see on here is the region that we need is shaded by both. So we can see that we've both got the green and the yellow, and that's the part that we want. It's where both are satisfied. Here we've got now that y is less than 2, but x isn't greater than 1. So therefore that doesn't satisfy it. It's this part right here. So entirely up to you on how you want to look at shading that. You could do it all at the end. So we can now test a point, and on this one now, if we tested a point, let's choose now this point. Let's just choose a point here, any point we want. So if I chose this point here, we've got the coordinates, x is 2 and y is going to be 1. So that's in the shaded region here. Is the x coordinate now bigger than 1? Yes it is, it's 2. Is the y coordinate less than 2? Yes it is, it's 1. Therefore that's in the region. If you tested the origin here where we've got 0, 0, well is 0 bigger than 1? No it isn't. So we can see that that doesn't satisfy it. It only satisfies the first. So this is R, and we just label it up like so. Okay, shade the region of points that satisfies y is equal to or greater than 1, yet in turn less than 3, and x is greater than 1. We need to label the region R. So what we're going to have here is a band. So I can include one on the y-axis. So what I'm going to do is go ahead and put this on. So we'll have this right here. So this is going to be now the line y is equal to 1. That can be included. Ideally, I'd like the same colour. I'm not going to change these so it doesn't look fantastic. And then what we've got are all of these points here. So that's what we have. That satisfies this one. So y is equal to or greater than 1. That's the line y is equal to 1. And that's the line y is equal to 3. Any point in here satisfies the first one. And then what we need to do then is put the next one on, and we'll put the next one on, and that is going to be x is greater than 1. So if I went ahead and labelled these up, what we have here is the line y is equal to 3. We've got y is equal to 1, and we've got x is equal to 1. So we need to ensure that it satisfies both of these inequalities. So nice and clear again, it's going to be this bit just here. So all I'm going to do is go ahead and shade that, and let's just shade that in with this one, something like so. I've gone over, and I apologise for going over. You won't go over because you'll put a ruler next to it and make it nice and pretty. But it's this region here, and we've got all of this as well. So we can call this region R. So R satisfies both y is equal to or greater than 1, yet in turn less than 3, and x is bigger than 1. Should we test a point? Well, clearly you can test any of these regions. There are different regions to choose. You can see the different regions. You could test that one, that one, that one, that one, that one, or that one. If we look at the one that we've chosen, for example, here, the coordinates now are 4, 2. So, is 4 bigger than 1? Yes, it is. That's the x-coordinate. Is 2 between 1 and 3? Yes, it is. Therefore, that is a region that satisfies it. All of those points in there will satisfy it. If we consider the integer solutions to this inequality, and we may as well look at it, that is one integer solution, this is another, and clearly we'll have loads in this direction. But if you were asked to name or list some integer solutions, we could have now 2, 2, we could have 2, 1, we could have 3, 1, we could have 3, 2, we could have 4, 1, we've just done 4, 2, we could have 5, 1, and we could have 5, 2. So you can see that all of those integer, and they're obviously going to be non-integer, so decimal and fractional answers that go in there. But that's just an example. We can't have anything that sits on these broken lines because it isn't included. So for example, this point right here has the coordinates 2, 3. Well, the x-coordinate clearly is bigger than 1, that's 2, but the y-coordinate has to be less than 3. It can't be equal to 3. Therefore, this point itself doesn't satisfy the region. Okay, right, shade the region of points that satisfies the inequality y is greater than x. So what we need to do here is draw y is equal to x. If you're comfortable with drawing straight lines using the gradient intercept method, that's perfectly fine. If you're not, you could do a table of values. So if you don't recognise a straight line equation, then you can go ahead and just build up a table of values. So if we've got now x and y, and we want a table of values for y is equal to x, well, when x is 0, y will be 0. When x is 1, y will be 1. When x is 2, y will be 2. When x is 3, y will be 3. What we have is a diagonal line through now 0, 0, 1, 1, 2, 2, and so on and so forth. Okay, so what we need then is y is greater than x. So let's just put this line on to start with, and that'll look something like so. So this is the line y is equal to x. What we need to do is get the correct side. Some people just see it, and some people just go straight for the notation and say, well, y is above x, so we go above this line. I would always test the point. So if we look at the point here now, this point is 0, 3. Is the y-coordinate bigger than the x-coordinate? Well, 3 is bigger than 0, so yes it is, and this satisfies it, so we would shade this side. If you wanted to look at a point here, what we'd have, this point is going to be 4, 2. Is the y-coordinate bigger than the x-coordinate? Well, 2 isn't bigger than 4, so this is not the region that we want. So you decide how you want to determine which region it is. Which side. You can either look at it and say, well, y is above x, so we're going above the line. You can do it purely on intuition, or you can consider points. And all we're going to do is shade above that. And I apologise that it's gone over the line. That's slack. But my control of the pen on here isn't brilliant. So we shade all of this in here, and we clearly define the label and label the region R. So R is going to go here. For any straight line, if you're not comfortable now with this particular gradient intercept method, you can always use a table of values. The nice thing is this topic is seen to be quite a good skill to be able to do, yet some people avoid doing it because they're not comfortable drawing straight line graphs. Just use a table of values. So for example, if we had y is equal to or less than 3x minus 1, and you thought, well, I don't know what that looks like, well, just draw a table of values. Just put the values in and go ahead and do them. So if we looked at this now, if we started now with values of x and we substituted in and put values of y, if x is 0, 3 lots of 0 is 0, minus 1 would give us negative 1. If x was 1, 3 lots of 1 is 3, minus 1 is 2. If x was 2, that's going to give me 3 lots of 2, which is 6, minus 1, which is 5. So what we can see here is that we've got these points here. So if you wanted to do it on this particular, and I'll just quickly do it on this one, we've got the point 1, 2, which is there, and we've got the point 2, 5, and that is just there. So all we need to do is draw a straight line through these, and we've accessed the question now, and it would look, as I say, something like this. Let's just put that in place, and you can draw that line. Then all you'd need to do is just think to yourself, which side of the line do I need to draw? But again, we'll look at that shortly. So don't be scared if you see a straight line equation and think, well, I can't do it with the gradient intercept method. The gradient intercept method is just picking the value of c, which is -1, and seeing that the gradient is 3. So this goes up 3 for everyone it goes across. You decide. Okay, let's do the next one. We're asked to shade the region of points that satisfies the inequalities y is greater than x and x is equal to or less than 4. So we've got 2 again. We've just drawn the line y is equal to x. That's a nice easy one. That looks something like so. So that's the line y is equal to x. So we want y greater than x, which is this side. But we've also got x is equal to or less than 4. So if we put that on, we need this line, solid line, x is equal to 4. So we need to be now to the left of this line. This is saying now that the x-coordinate is 4 or less. So we can have 4, 3, 2, 1, 0, and anything to the left of this line. So if I just go ahead and write this on, this is the line y is equal to x. So y is equal to x, and this one is x is equal to 4. If you shaded once and then shaded twice, entirely up to you on how you want to do it. I would prefer to have my pencil to show you how to do this, of light shading and dark shading. But essentially, if I do it double shading, you'll see. So on this one, where is y greater than x? Well, that's going to be above this line here. So we would shade all of this right here. Then we would say to ourselves, where is x going to be equal to or greater than 4? Well, that's to the left of the line. So what we'd have to the left of the line, let's change the colour. We would have all of this right here. So what we want now is the region that is shaded or shaded yellow and shaded green. So it's got both of them because it needs to satisfy both of these. So we can see here that it's not this part here and it's not going to be this part here. So what we do is just get rid of this and we get rid of this right here. So let's go ahead and do that. Let's just kill all of this and it will look something like so. So it's where we've got both yellow and green. And that gives us that. That's what we've got. And we can just go ahead and call this R. So let's put R on here. This is R. So that one's done. Okay, here we go. Shade the region of points that satisfies y is equal to 2x plus 1 and y is less. So y is equal to or greater than 2x plus 1 and y is less than 5. So if you're not confident, I'll do this. Let me do this with the gradient intercept method. So with the gradient intercept method, what we do is simply write the line, and what we'll do is the line y is equal to 2x plus 1. So the c value on this is 1, so that's where it crosses the y-axis, and the gradient is 2. So this goes 1 across and 2 up. It goes 1 across and 2 up. So that gives me my line y is equal to 2x plus 1. I can include this line because we can see on here now that the inequality is included and it will look something like so. So that is that line there. So y is equal to 2x plus 1. Let's say though you weren't confident in using that method, and that is perfectly fine. That is the gradient intercept method. What I'm going to do instead now is build up a table of values. So y is equal to 2x plus 1. So we'll have x and we'll have y. 0, this will give us 1. 1, that will give us 3. 2 will give us 5. So all I'm doing is substituting in. When x is 0, 2 lots of 0 plus 1 is 1. When x is 1, 2 lots of 1 plus 1 is 3. When x is 2, 2 lots of 2 plus 1 is 5. And you can see we've got 0, 1, 0, 1, 1, 3, 2, 5, and that's what we've got. So what we want then is y is equal to or greater than 2x plus 1. So what we're doing is shading above the line. So on this one, we shade above the line. If this had been the other way around and it was y was equal to or less than 2x plus 1, we would go below the line. Again, if you want to test a point, you can do. You can test either one in the region or out the region. If we test the origin here, 0, 0. So is 0 bigger now than 2 lots of 0 plus 1, which is 1, The answer is no, therefore that's outside. Yet if you look at this point just here, and we could have chosen one on here, it really doesn't matter, we've got 1, 5. Is 5 bigger than 2 lots of 1 plus 1? Yes it is, because 2 lots of 1 plus 1 is 3, so this is inside. So that satisfies the first one. What we now want is that y is less and strictly less than 5, so we find the line y is equal to 5, and we have a broken line going across. So this is a line y is equal to 5. We need y to be less than 5. So it's all of these points below. So again, you could double shade on that, or you could simply now take out the bit above this line. So the region of points, let's go ahead and look at those. The regions of points that satisfy both of those inequalities are going to be now right here, all of this below the line. And again, I appreciate I've stumbled above it. I could spend hours tidying this up. Please do, though, if you're in an exam. That wouldn't be acceptable because it's just awful. But there we go, that's a bit better. So this is the shaded region, which you do with a nice pencil. Mechanical pencils are always the best. I love them. And that's what you get, that's a region. So that's the region that satisfies those points. Again, if you're unsure, just test the point. Test this point right here. This point has the coordinates 1, 4. Does that work? Well, if we look at it now, here, is 4 bigger than 2 lots of 1, which is 2 plus 1? Yes, it is. That works. Yet if you tested a point just here, which is going to be 1, 6, all we want to do on here now is test if that satisfies it. Well, it doesn't, because the y coordinate has got to be less than 5. 6 is not less than 5. If you want to test a point out here, this point is 3, 4. Is 4 bigger than 2 lots of 3 plus 1? No, it isn't. 4 is not bigger than 7, so that isn't satisfied. So again, you've got all these check-in techniques and mechanisms if you wish. Right, shade the region of points that satisfy x plus y is less than 5. The easiest way for me to graph this line, and I'll show you a couple of different ways. Some people like to rearrange it as y is going to be less than minus or negative x plus 5, or y is less than 5 minus x. I prefer to do it a different way. If x was 0, y would have to be 5 to give 5. If y was 0, x would have to be 5 to give 5. So all we would do is simply plot these points. So we'd have 0, 5, and we'd have 5, 0, and that's what we end up with. So we need a broken line here, and we'll put the broken line on. That's going to be the line now. X plus y is equal to 5. So let's just put this on here. This is x plus y is equal to 5. So just think about it. If x is 0, y's got to be 5. If y is 0, x has got to be 5. So we want the points now that are less than that. Well, all we have to do at this stage is simply shade now below the line. So if you think about a point here, this is 0, 0. Is 0 plus 0 less than 5? Well, quite clearly, let's just make that look like a 0. Is 0 plus 0 less than 5? Certainly is. Yet if you look at this point just here, this is 4, 5. Is 4 plus 5 less than 5? No, it isn't. So again, we shade below the line. You might want to look at this again and think to yourself, can I see from here which it is? I personally don't prefer that method. I just like to consider points. So this is the region we're in. And I'd really, really like this to be nice and accurate. But again, it would take an eternity to do. So it's all of this below here. We also need the points now where x is going to be greater than 2. So all I'm going to do is simply put the line x is equal to 2 just here. We know that that's a vertical line, and it needs to be bigger. So what we need to do is shade points that are both below the diagonal line we've got, this x plus y is equal to 5, but also bigger than 2, x is bigger than 2, so to the right of 2. So what we end up with is all of this point just here. So we end up with this part just here, and that'll look something like so. So this is what we have. So it's just now the green bit. So what we would have to do at this stage is now get rid of the yellow that is lying to the left of this line. Satisfies one but doesn't satisfy both. It must satisfy both. And again, if you want, you can test a point and label that region R. So it's in here. I'll put it on as R. And test a point. Test a point that you want. If you pick this point right here, we've got 3, 1. So, is 3 plus 1 less than 5? Yes, it is. It's 4. Is 3 bigger than 2? Yes, it is. So, it's in there. If you tested this point just here, this is 4, 3. So, is 4 plus 3 less than 5? No, it isn't. It's 7. That's outside. So, you can test this region, this region, this region, and this region if you want to confirm that you're right or otherwise. But again, hopefully now you're fairly happy with this. Right, okay, so what we want now, it says shade the region of points that satisfy y is less and strictly less than x plus 1, x is bigger than 2, and y is equal to or less than 5. We're asked to label the region R. In part B it says state how many points with integer coordinates satisfy the inequalities. I think these should be these ones, shouldn't they? So let's change those because that doesn't look right, does it? Y is less than x plus 1. X is going to be bigger than 2, and then we've got y. It will just switch in these ones. I think that's what it's meant to do. I don't think, looks like these two aren't associated. So let's go ahead. Right, y is less than x plus 1. If you're confident to draw the line y is equal to x plus 1, what we have is a y-intercept of 1 and a gradient of 1. This will look something like so. So that's what we've got. If not, and we can just label that up, this is just going to have a line y is equal to x plus 1. If you weren't, you could draw a little table of values. Table of values is perfectly fine. I prefer people to draw a table of values and just say, I'm not happy with drawing a straight line from a gradient and intercept rather than leaving it. Y is equal to x plus 1. So for values of x, we get a y. If x is 0, that's going to give us 1. If x is 1, that's going to give us 2. We're just adding 1 to it. 2, 3, 3, 4, 4, 5. And you can see for all of those points there. 0, 1, 1, 2, 2, 3, 3, 4, 4, 5. Now, we want that x plus 1 is bigger than y. So we need to shade this side of the line. I'll do this as I go. So let's go ahead and do that, and let's just do it with this purple pen. So that now satisfies this particular region. Again, if you're unsure, just pick a point. So if we pick this point right here, in fact, let's just pick this one. This point is 4, 1. So is 4 plus 1 bigger than 1? Well, yes, it is. So we know that it's to this side of the line. Again, you could look at it and say, well, the x is bigger than the y. Just be careful on that way. Next one, x is bigger than 2. So that's that line right there. So x is going to be bigger than 2. So x is, on that one, x is bigger than 2, which is going to be to this side of the line. And then what we need, so we can get rid of this bit now, can't we? So x is going to be bigger than 2. And what we also need now is that y is going to be equal to or less than 5. So what we end up with now is this line, and this is the line y is equal to 5. So y is equal to 5 is just there. And we need it to be equal to or less than 5. So it's going to be below this line. So what we have then is the following. And I'll just do this in one go. We're going to have all of this. And so what we get on our diagram here is now a little, and what's this? This is a trapezium, isn't it? So let's look at the trapezium. That looks a bit like a trapezium to me. Let's put that like so. Is that? Yeah, there we go. So this is the region that we have. So let's reword this question, because I think this part of the question is wrong. What it might do is ask, now it says state how many points with integer coordinates satisfy the inequality. Well, infinitely many, because it's going to keep going in this direction. We're just going to get more and more over here. So whenever you've got, for example, this one here, we got 5, 3. Well, we'll have now 6, 3, 7, 3, 1 billion, trillion, whatever, 3. So let's just put on here, we'll shade this region R. So what we've done is satisfied the region in terms of the graph. This obviously will keep going. What we could do now is introduce, in fact, let's make it slightly more interesting. X is going to be bigger than 2, yet in turn what we'll have now is equal to or less than 4. Let's make this slightly so it's actually worth doing, because I think that last bit of the question is rubbish. So That now is for line x is equal to 4. So now if we wanted this region but satisfied all of that, we'd have to get rid of this. So let's now look at some integer coordinates that satisfy all of these. So what I've done, I've taken out x is bigger than 2 and swapped it for x is greater than 2, yet in turn equal to or less than 4. So if we look now at some integer values that satisfy this based on the grid that we've got, we can see now that this would, so that's 3, 0, 4, 0, we would have 4, 1, we would have 3, 1, we'd have on here 3, 2, we'd have 4, 2, we would have 3, 3, we would have 4, 3, we'd have now 4, 4. So they're all integers that will satisfy the inequality that I've just done. So we've done a bit of butchering with that last one because I really don't think it was worded correctly. So there we go. That's hopefully by now you're fairly fluent with this and fairly confident. So let's look at a slightly different skill. We've labelled it R and job done. In this one, we might be given now inequalities and be asked, represented graphically inequalities, we might be asked to state what they are. Well, if we look at this one now, what we need to do is state the inequalities shown in each of the graphs. So we can see now this is the line y is equal to 3. It's shaded above the line and it's a broken line. So we can say that y is going to be greater and strictly greater than 3. This one here, we've got a vertical line. We know vertical lines are x's and horizontal lines are y's. So this one now, this is the line x is equal to 1. We can see that it's shaded to the right, so that means it's going to be bigger than 1. But because we've got now the solid line, we can say that x is going to be equal to or greater than 1. And that is the region that this inequality represents. Okay, let's have a look at this right here. Okay, certainly what we've got here is the line y is equal to 3. So y is equal to 3, so y is equal to 3. Looking at this right here, this looks to be the line y is equal to x. We'll just check it just to see. So that should give me 1, 1. So because we don't have a grid on this, that should give me 2, 2. This should give me 3, 3. So that's perfectly fine. That is the line y is equal to x. Needed to check. So this is the line y is equal to x. So on here, what we can see now is the following. We can see that y is going to be equal to or greater than 3 because we're shading above this line. Yet what we're going to have is y is going to be equal to or less than x because we're shading below this line. So if we think about a point in here, this point should be in there, which is 5, 4. So x is 5, y is 4. Is the y coordinate equal to or greater than 3? Yes, it is. It's 4. Is the x coordinate bigger than the y coordinate? Yes, 5 is bigger than 4. So that is that one. Right. Let's have a look at this one. This one looks quite good. So here we've got this point 0, 6. And let's look at this. This is 0, 6, and this one is 6, 0. So what we can see, this is shaded, and let's just write out, this is going to be x plus y is equal to 6. We saw this before, or y is equal to 6 minus x. I prefer to write it like that, but you can write it in the form y is equal to mx plus c. You just need to change around. So that's that. Now we can see that it's below that. So straight off, I'm going to say that x plus y is going to be equal to or less than 6. That would be all of this. If we look at this line here, this is the line x is equal to 2. So we can see now it's a solid line and we shade it to the right. So this one is going to be x is going to be equal to or greater than 2. So they are the two inequalities that this satisfies. If we chose a point here, 3, 1, let's see if it works. X plus y is equal to or less than 6. Well, 3 plus 1 is 4, so that works for the first one. The x coordinate is equal to or greater than 2. Yes, it is. It's 3, so that works. So that point is in the region. So we can test that point. So there we go. Shading regions or representing inequalities graphically. Hopefully, I'm a bit disappointed with the wording of that question, but hopefully by the time we got there, you had all of the skills to spot how we could alter this and be a bit more flexible.